For skill practice 6, we are evaluating the sine of the inverse tangent, and we need to recall that the inverse tangent is restricted to negative pi over 2 to pi over 2, not inclusive. And if we have the tangent of 12 over 5, that means the tangent is positive, and tangent is only positive in the first or third quadrants. In order to be in the correct interval for tangent and be positive, this means we're in the first quadrant. So I can draw a triangle in the first quadrant for the angle theta, whose opposite is 12 and adjacent is 5. This is a Pythagorean triple, the 5, 12, 13. If you don't recognize that, you can find that by saying the square root of 5 squared plus 12 squared equals that hypotenuse. And then we just find the sine. The sine of that same angle is going to be 12 over 13. For question 7, we are finding the cosine of the inverse sine. And remember that sine is restricted also between negative pi over 2 and pi over 2. But in this case, it can equal pi over 2. It doesn't have the restriction that tangent does. The sine is negative. Well, sine is only negative when y is negative, which happens in the third and fourth quadrants. But to be restricted on that interval from negative pi over 2 to pi over 2, and for sine to be negative, I have to be in the fourth quadrant. I'm going to draw a triangle here with the angle theta. Sine of that is 2 over 11. So we have negative 2 for the y, 11 is the hypotenuse, and we need to find the adjacent side. 11 squared must be equal to the adjacent side squared plus the opposite side squared. 121 equals a squared plus 4, or a is equal to the square root of 117. The cosine of theta is then the square root of 117 over the hypotenuse of 11. For skill practice 8, inverse sine is restricted from negative pi over 2 to pi over 2. We are told that x needs to be positive. We can draw a triangle for angle theta where the inverse sine of x over the square root of x squared plus 9 is equal to theta. That's saying that the sine of theta is equal to x over the square root of x squared plus 9. That's telling me that the opposite value is x, and the hypotenuse is x squared plus 9 square rooted. So we need to figure out what the adjacent side is. So we can use the Pythagorean theorem to figure that out. Squaring a square root cancels. That leaves us with a squared equals x squared plus 9 minus x squared. If I move this x squared to the other side. A squared is then equal to 9, or a is equal to 3. And then the tangent of theta is then equal to the opposite of x over the adjacent of 3. Skill practice 9 says that for the construction of a house, a 16 by 6 wooden frame is made. They want to find the angle that the diagonal beam makes. That 16 foot at the top is the same thing here. And when I'm relating this triangle, I see that for theta, I have opposite over adjacent. That means that the tangent of theta is equal to 6 over 16. Or the inverse tangent of 6 over 16 is equal to theta. And we need to use degrees here based on what they've told us in the question. So on our calculator, we would do inverse tangent 6 over 16, and we would find that theta is approximately 20.6 degrees. For the last problems in this chapter, we're going to be dealing with the inverse secant and the inverse cotangent. When we define the function to be y equals the inverse secant of x, That's the same thing as saying that the secant of y is equal to x. And we know that our y value has to be between 0 and pi, but cannot equal pi over 2. When we have the inverse secant of -4, what we're trying to figure out is some angle theta in radians here. And so we're going to replace the y with our theta. The secant inverse of -4 is the same thing as saying that the secant of theta is going to be equal to -4. We're trying to figure out what that theta value is, and it has to be between 0 and pi, but it cannot be pi over 2 based on our information here when we are defining the secant of y is the same thing as the secant and theta, so y and theta are under the same restrictions. Recall that the inverse cosine and the inverse secant have the same range when x is not equal to 0. Then we can say that the secant of theta equaling -4 implies that the reciprocal cosine equals -4. Solving for cosine, that's the same thing as saying that the cosine of theta is equal to -1/4, or the inverse cosine of -1/4 is equal to theta. Finding the inverse cosine of -1/4 in our calculator in radians, we find that theta is approximately 1.8235. For part B, we need to approach this just slightly differently because we're talking about the cotangent, which is between 0 and pi. But since the value -5/12 is negative, we know that this is going to be in the second quadrant because the first quadrant is positive. So we need to, using the inverse tangent isn't going to get us a second quadrant angle on our calculator. So what we want to do is we want to write it using a cosine function to be able to get a second quadrant angle. So if we have the cotangent inverse of -5/12, that's saying that we have the cotangent of some theta equal to -5/12. And remember that cotangent is x over y. So we have an x value of -5 and a y value of 12. So imagine this here. Then our r value, this is a Pythagorean triple. You recognize -5 squared plus 12 squared is going to be equal to r squared. Our r value is then 13. We can use the inverse cosine then to find the same value of this theta. And cosine is adjacent over hypotenuse, or our x value over our r. In this case, since it's an obtuse angle. This means that the cosine inverse of -5/13 is going to be equal to our theta value, which is approximately 1.9656. Thanks for watching. That's it for this chapter.